been working on this estimate for hours. Why is road construction so complicated? Separate fill, aggregate base, sand. Oh, I swear, if there was just an advanced technology that could help me compute everything, I'd finish this already.
Hi, engineer! This is TriCE estimation suit. Welcome. Is there anything else we can help? Oh, sorry, my bad. Let me introduce first what TriCE estimation is. TriCE estimation suit is designed to help civil engineers on calculating or computing road construction, concrete mix, and soil bearing capacity. But before we go further, let me tell you that you always had a choice. Yes, you always had a choice to do what you want. So, for the first option, we have materials and definition. Oh wait, let me call someone who will introduce that to you.
Hello engineer, I am here to explain to you the function of our choice 1, materials and its definition. I mean, it's kinda obvious from the name itself what this operation is for. But still, I will explain it to you because always remember, you matter in TriCE. So to start with our discussion, materials and its definition simply tell us the purpose and the usage of each material. Under this, you will have 3 operation categories to choose from: road construction, concrete mix, and soil mix. These 3 operations are basically what makes TriCE exist. To begin using this function, of course, you have to input number 1 in the main menu to select materials and its definition. After that, you will be asked to choose from the 3 available operations, depending on which group of materials you want to learn more about. Next, the system will ask if you want to view the definition of the material. If you choose yes, the program will prompt you to enter the specific material you want to know about. If you choose no, the program will immediately return you to the main menu to check if you need further assistance. That's material and its definition choice.
Option number 2, the show material unit cost.
So with this one, after choosing option number 2, it will just simply show the material unit cost. We also have option number 3, which is calculate the road construction. So, the program asks the user to input the road's length and width. It calculates the volume or area, then multiplies it by the unit price of the chosen material, concrete, asphalt, or gravel. If the user enters a material that isn't one of these, the program tells them that it is invalid.
We also offer concrete mix ratio.
For this part of the program, I will be explaining the concrete mix ratio calculator, which activates when the user selects option 4 in our system. The code begins with elif choice equals 4. This indicates that when the user chose option 4 in the menu, the program proceeds to run the concrete mix ratio calculator. To begin, the program prints a formatted title using line and center text. This helps make the interface clean, organized, and easy to read for the user. Next, inside the try block, the program requests 2 inputs from the user. First, the total volume of concrete needed in cubic meters. Second, the mix ratio, which represents the proportion of cement, sand, and gravel. Following this, The input ratio is split using a delimiter, then converted into integers. These values are stored as cement ratio, sand ratio, and gravel ratio. Afterward, the program computes the total parts, which is the sum of all proportions. Once these values are established, the program calculates the exact material quantities based on the ratio and the given formula. After determining each material quantity, the program then proceeds to calculate the cost of each material. Subsequently, after computing the quantities and costs, the program prints a clean table that shows the amount of each material along with its corresponding price. Finally, the variable cost adds all material costs together, giving the user an estimated total cost of the project. While in cases where the user enters an invalid value, for examples, letters instead of numbers, the except value error part is triggered. The system then displays invalid input. Please follow the given format to remind the user to provide the exact correct input format.
The said soil bearing capacity.
The soil bearing capacity evaluator will help us determine whether a given soil can safely support the load of a building foundation. Computing the safe bearing capacity follows the Terzaghi's equation, wherein it is stated that the summation of soil cohesion multiplied to the bearing capacity factor of cohesion plus overburden pressure times the bearing capacity factor of overburden pressure plus the product of 1/2 gamma with foundation and bearing capacity factor of gamma is equal to the ultimate bearing capacity divided by the factor of safety equal the safe bearing capacity. For example, you have sand with a soil cohesion of 25 kN per square meter, 18 kN per cubic meter of gamma, a foundation depth of 1.5 meter, and a foundation width of 1 meter with a factor of safety of 3. Solving it manually will take you a minute, but using our suit, you'll be able to solve it in seconds. The calculated safe bearing capacity is 483.63 kN per square meter. Therefore, the soil is suitable for shallow foundations.
And for you to know more about this TriCE, we include the frequently asked question about what TriCE is and more questions.
After the user enters the 6th option, the program will show all the frequently asked questions or facts. This is all about information about the TriCE estimation suit that users would like to know. For instance, these are the questions that are shown on the screen. The program will prompt the user to choose from these frequently asked questions, and after the user chooses which question they want to know about, TriCE estimation suite will now provide the answer to that specific question.
Lastly, you had a choice to exit.
And lastly, option 7, exit. The program will display "Thank you for using TriCE estimation suite," marking the end of the program.
We hope that one day we can help you do whatever you are calculating with.